Thank you, sweetheart. Did you just make a face when you walked by?
Maybe. Y'all saw nothing. Getting attacked. Getting attacked.
I have offline. Because this is Texas. You gotta be smarter than that. I'm just kidding. You rushed out here to help me. I appreciate it. What's up, everybody? Don't adjust your screen. I'm in a cast because I'm an idiot. This is my daughter, Jaden.
Hello.
She's going to help me. We're going to attempt to shoot the International Space Station tonight with our 12-inch Apertura Dobsonian. We've done it before. The telescope won't reach focus without a Barlow, so you have to use a Barlow, which is going to increase your magnification. And then also with the planetary camera, your field of view is going to be extremely small. So I'll point the telescope and she will be manning the computer and adjusting exposure because, number one, the space station changes apparent magnitude depending on where it is over the horizon. And also we have low-level clouds in the air. So if we expose for below the clouds, then when it gets above the clouds, it's going to be blown out, and having a second person helping you out is necessary. I wouldn't say absolutely necessary, but it'll definitely help you keep your sanity, because if you try to do all this by yourself and you fail, then you know you're going to have wasted time and you could have been doing something else.
I could have imagined you trying to do it with your cast.
When I did it with her the very first time back in June, I believe, we got a really nice time lapse of the space station crossing over. It was actually the week after SpaceX launched the astronauts into space. So anyway, Jaden, do you want to show? So we have the AD-12, and then also on top we have a right angle finder scope. That finder scope is 100% perfectly centered with the camera. Before we got started, we pointed to Jupiter. I don't know if you can see Jupiter up there.
It's really bright.
But we pointed to Jupiter and we centered Jupiter in the computer, and then I made sure the crosshairs were centered, and that is 100% critical, because when you're tracking the space station going across the sky, even if you think you're on the crosshairs, it's not going to even register on the computer because that thing scoots. So double check that. Also, as a handy reference, you can check, Jupiter's magnitude, which is negative 2.1, and then the brightest that the space station is going to get tonight is negative 3.1. So we know that if Jupiter is properly exposed, then the space station will be overexposed. So that's also handy to know. And the focuser, this way, we have the Crayford focuser, we have a 2x Barlow, and then the ASI 290mm. And on the 290mm is just a luminance filter, and that's hooked up to the computer. Pretty much all there is to it. It's point and shoot, but it definitely helps to have somebody else helping you while you're trying to aim, and also to check exposure. Thank you for that. Helping your dear old dad. So anyway, we'll get started and see what happens. There's different apps and websites that will give you alerts for the space station. One of the ones I use is Astrospheric. It's basically a weather app for astronomy all in one. So it shows you transparency and seeing in cloud conditions and stuff like that. But it also has a alert for the space station, and it gives you a star chart on which direction it is and its path and everything. But what I like to also do is I'll take that information and I'll put it into Stellarium, either on the computer or on my phone, and it gives you an exact path. That way you can visualize where it will be in the night, and you can plan for it, whether it's shooting it with a telescope or getting a long exposure wide field view or whatever. We got an alert for the space station on September 14th at 8:40. Instead of making an entire arc across the sky, it will disappear into the Earth's shadow. So in order to get an idea of where it will be when it breaks the horizon and where it will be when it disappears and the path it takes through there, we can look into Stellarium either on the computer or on your phone, and you can get a perfect visualization, and it's down to the second, so there's no guesswork. So here we have 8:40 p.m. and 43 seconds. Now this is site specific, so this is Central Standard Time. but you can see it's breaking the horizon. So if you click on the space station, the most important number you want to look at is approximate magnitude. The lower the number this is, the brighter the object is. So right now you can see it's 0.71. To get a good visual representation of how bright something is, you can use something that's a known brightness, like let's say Jupiter. So Jupiter is negative 2.5 magnitude. So if you're looking in the sky and you can see Jupiter, that is negative 2.5 magnitude. Well, if you plan out the space station and if you pay attention to that approximate magnitude number, then you'll know how bright the ISS will look whenever it's going across the sky. So now if we play this forward, you can see that number as it gets over the horizon and up in the sky drastically increases. Well, decreases in magnitude, but it gets brighter and brighter. And we'll keep going. You can see it's going through the Milky Way. It's going towards Jupiter. And they'll reach a point where it reaches maximum brightness. Okay, so right now at 8:44 and 35 seconds, it's right between Jupiter and Saturn at -3 magnitude. So it will be a half a magnitude brighter than Jupiter. We'll go ahead and play it again. You see it's still getting brighter and brighter. So it's been riding at -3.26 for a while. So -3.26 is going to be its maximum brightness, which that's about as bright as it always gets from here when it's directly overhead. And at that moment, it will be, without the moon or Venus, the International Space Station will be the brightest object in the sky. And it's moving incredibly fast, so you really can't miss it. Go ahead and play it again. So I don't know if you saw that or not. Let's center it and we'll zoom in. So this particular instance, the space station will actually go into Earth's shadow. So it will get, it's going from peak brightness to dim almost instantly. It'll take a couple of seconds, but I mean, you can see right there, it just disappears and now it's back to 17 magnitude, which you can't even see. But what it does show you is where in the sky it will do that. So if we look, zoom out a little bit more. So in the southeastern sky is where it will disappear. Oh yeah, and spacebar centers it and tracks it for you. Another thing you'll notice about the space station is while it's on the horizon, it appears to be moving slow. That's just because it's having to go through, you're looking at it through all that atmosphere, and then as it gets closer to overhead, you're looking at it in a more direct line of sight. Imagine a car on a highway, and you're standing on the side of the highway, you can see that car coming from a really long way away. And then as it gets closer to you, it appears to be going faster until it just zooms by you. And then it goes the other way. Same thing. But anyway, that's stellarium. That's one way you can use to visualize and plan your space station photography, whether it's with a telescope or wide field, or you just want to look at it and show everybody, hey, that's the space station.
2.5, so it's going to be brighter than Jupiter.
So you're probably going to have to tone down on the exposure.
I don't see anything on the screen. Can I press play?
That's it? Alright, play.
Okay. I don't see anything.
Still don't?
Nope. Nope. I saw something. Okay. Okay. Right. There.
sucks with a cast.
There you go. Up. Here's something. You had something again? You keep on getting little bits of it.
That's fine. Oh damn, it's right underneath Jupiter. You see it up there?
Yep. Oh, you had it.
There's Saturn.
Mm-hmm.
Ah.
And this.
Oh, look how bright it got now.
Yeah. Oh, there's nothing up. Yep, there's something. Okay.
This is really hard to do. But watch, it's about to disappear.
I can walk
It's going to go into the Earth's shadow and disappear.
in it. Whoa.
See how dim it's getting? Look at that.
Mm-hmm. Oh.
Alright, stop. Woo!
Yeah. You look tired already.
Oh,
You're just like all over the place.
that was not fun at all. I didn't realize it was going to pass between. I didn't look at the track. So now we can go.
Ignore the first one.
Well, that was fun. Did you have fun?
Yes.
So this
It's
your
always entertaining.
well, it's your
It's funny.
So it's your second time doing it. First off, how old are you?
14.
14.
I'm old.
So this is your second time shooting the space station with me.
Yes.
If you had to offer advice to either father-daughter, father-son, husband-wife, boyfriend-girlfriend, teams of people out there, what would your advice as the computer monitor be?
Always make sure to tell them whatever you're shooting is in frame, and try and focus depending on whenever you see whatever you're shooting. Make sure that you adjust the exposure. You can always adjust it little by little, but sometimes I do it a little bit more when I can tell it needs it. So always look for that little.
Love you.
Yeah.
See y'all later.
Bye.